Hello everyone. So in this video we will see 2026 JEE advanced questions which is based on NCERT textbook only, and because of that NCERT textbook based question means people think that it is the one of the most difficult questions asked in JEE advanced examination in this year. What happens for previous year, the JEE mains and JEE advanced examination, they are asking something different from the textbook. Concept is taking there from the textbook, but the level is little bit high, more high. But this time the trend has changed. They have asked a very simple questions which are based on the NCERT textbook only in the JEE advanced examination. You never imagine. And this question is also based on NCERT textbook only, but this is deeper way, the deeper concept of the NCERT textbook, and because of that the people think that it is one of the most difficult question asked in JEE Advanced 2026 in mathematics paper. Now how to do this? See, the question says that let S is the set containing these elements 1, 2, 3, 10. That is cardinality. Order of the set is 10. Okay, containing 1, 2, 3, 4 up to the 10 element. Number 1. And now consider the set S which contain R. What is R? R is an equivalence relation on the set S. R is an equivalence relation which is defined on the set S. See, set S, R is defined means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9, 10, 10. These element has to be there in R. Correct? So that it may be, it is a reflexive relation. But we want those relation R which exactly contains 42 elements. Apart from these 10 elements, you have to search other 32 elements which follows the equivalence rules, that is reflexive, symmetric and transitive as well. But for reflexive you must have this 1 comma 1 2 2 2 comma 2 3 comma 3 up to the 10 comma 10. So how to calculate? That is important. So do you have any idea to do these questions or any concept regarding this question? There is a concept, but very uncommon concept, because that concept even CBSE there is no question, mains and advanced also there is no question, but this time they have asked the question based on this concept. Now to solve this question we will understand in that way. See, suppose that I am having a set containing 3 elements. Okay. So I will make the, now I am explaining the concept. Make the partition of this set. I will make the partition like that. Say A1 is containing 1 and 2 and A2 containing 3. So what you are observing, number 1 is that A1 union A2 is S. Number 2 you are observing that A1 intersection A2 is empty, and number 3 you are observing that A1 and A2 both are non-empty sets. Both are non-empty sets. So I am making the partition of set S like that. I have partitioned the set S into A1 and A2 such that A1 and A2 are disjoint sets, that is they have no common element, and also their union gives whole set S, and A1 and A2 are non-empty sets. These 3 conditions we have seen over here. Now what happens, you want an equivalence relation defined on set S. So for reflexivity you want 1 1 2 2 3 3, that is make sure that these element has to be present. Correct? For equivalence relation has to be reflexive. Now how to do that? See, now the concept is coming that if I will take A1 cross A2, this will give 1 1 2 2 1 2 2 1, and definitely this A1 cross A2 is an equivalence relation defined on this A1. Correct? This is an equivalence relation, but I want to define the equivalence relation on S. So 1 1 2 2 and 3 3 has to be there, and apart from those all other elements which satisfy that symmetricity and transitivity relation. Correct? And so fine, but you can find out A2 cross A2 here. This is 3 cross 3. Now when we make the union A1 cross A2, A1 cross A1, this is A1 cross A1, this is A2 cross A2, correct? So A1 cross A1 union A2 cross A2. What we will observe? We will have 1 1, 2 2, 3 3, 1 2 and 2 1. So these are the elements present here in this set, that is union of A1 cross A1 into A2 cross A2. And definitely this relation is an equivalence relation. You can observe that. And you can say that this equivalence relation is defined on this set 1 2 3. Correct? This is also an equivalence relation. This also is an equivalence relation. This also is an equivalence relation. But this relation, which is an equivalence relation, you can say that this is defined on set 1 2 3. And this equivalence relation contains how many elements? 1, 2, 3, 4 and 5. 5 elements are exactly present in this equivalence relation defined on the set S. Correct? Now, the important point is that the n of A1 is 2, n of A2 is 1 and n of S is 3. So this condition is satisfied. This relation is also equivalent relation, but this will not satisfy this condition. This is also an equivalence relation, but not satisfied by this condition. And this is an equivalence relation which is satisfied by this condition. That is, R is an equivalence relation defined on the S set S such that R has exactly some elements. For example, here 5 elements. So R has exactly 5 elements which is defined on the set S. So in that way we can solve this question. We have to find out the number of an equivalence relation defined over the set S containing these 10 elements. I am explaining this question on the basis of this set S containing 1, 2 and 3. Correct? And it has exactly 5 elements like that. Now look at here. N of A1 is 2, n of A2 is 1, and we are observing that the union of A1 cross A1 and A2 cross A2, union of A1 cross A1 and A2 cross A2 is an equivalence relation which satisfies this condition. This condition means here whatever be the number of elements like that, here 5 elements, correct? Got it? So what we are observing that to find out, to solve this question, first one is that we have to partition this given set in such a way that this A1 union A2 is S, that is n of A1 plus n of A2 must be equal to n of S, and also the total number of elements you can observe over here is 5, which is given by 2 chi square plus 1 chi square, that is 5. Correct? 2 chi square plus 1 chi square, that is 5. This concept 2 chi square plus 1 chi square is 5. So the concept is that when we partition this given set in such a way that then the union of these two sets or this type of sets always give an equivalence relation satisfying the condition, and this condition is also important. I hope that you can understand this question now very easily. See, here in this question we are having n of S equal to 10. Now I will make the partition. Okay, so partition is like that. First one is 6, 2, 1, 1. Correct? So 6 plus 2, 8, 8 plus 1, 9, 9 plus 1 is 10. N of S is 10. So first condition is okay. Now the number of elements which are present in equivalence relation is 42. That is 36 plus 4 plus 1 plus 1, that is 42. And when we do the partition of this set in such a way that satisfies that condition, that is the union of all the sets is original set S, and each set is in means sets are pairwise disjoint sets, and the number of elements which are present on the equivalent sets, equivalent relation, the set containing 6 elements, these are elements which are related with each other. These elements cannot be related with the element of this set, and element of this set cannot be related with this element of this set. These elements are related with each other. Correct? Got it? For example, here we are having now this is 1 2 3, this is 1 2, and this is 3. Then we have 1 1 2 2 1 2 and 2 1, and finally 3 3. This is an equivalence relation where this 1 2 are related with each other. 1 1 2 2 or 1 2 or 2 1. 1 3 you cannot have there. 2 3 you cannot have there. Correct? 3 2 you cannot have. 3 1 you cannot have. And 3 is related with 3 itself. 3 3. So this relation is definitely an equivalence relation. Got it? Okay. Now here also we have participant, means this set is partitioned into the set containing 6 elements, 2 element, 1 element, 1 element. All these partitions are disjoint sets, and their union is set S. Can we have another way to partition this n of s equal to 10? Yes, we can have 5, 4 and 1. And 5 square is 25, is 60, 41, 1 ka square is 1, again 42. So these are the two ways we can partition. And definitely now the relation which is formed by the element of these partitions of sets is going to be an equivalence relation, and that contains exactly 42 elements. So how we can partition? Make the group. 10 is divided into 6, 2, 2 and 1, or 10 is divided into 5, 4 and 1. So how many number of ways? 10 factorial divided by 6 factorial, 2 factorial, 2 factorial, 1 factorial, 1 upon 2 factorial, because 2 has come 2 times first, plus 10 factorial divided by 5 factorial, 4 factorial, 1 factorial, that's it. Now you have to calculate this. So what is this one? This is 10 into 9 into 8 into 7, 6 factorial cancel out. This is 2 into 2 into 2, that is 8, 8 cancel out. 90 into 7. Correct? Na? Calculation is okay? No, not like that. This is 10 to 1 1. This is 10 to 1 1. Correct? 6 to 1 1. So this is 1 factorial, 2 factorial, 1 factorial, and again 1 factorial and 1 factorial. Okay, fine. So this is what? 2 into 2, that is 4. 4 to the 8. So 90 into 40. 90 into 2, 180. 180 into 7, 70. 6, 5, 12. 1260. 1260 is answer. Because we have to find out the partition of 10 as 6 to 1 1. Correct? 6 to 1 1. And then 5 4 1. Correct? This 6 to 1 1 must be 10. This 5 plus 4 plus 1 must be 10. And also the elements, the Cartesian product formed by the elements of this set only. Okay, they are not at all related with the elements of this set. Correct? So that is important. Okay, fine. And then this is 10 factorial, means 10 into 9 into 8 into 7 into 6, 5 factorial cancel out, 4 factorial is 24. 24. 6 4 ja, 4 2 ja. Then again it is 90 into 2 into 7. Again it is 1260. So final answer is your 2 into 1260. That is 0, 1, 5, 2520 is your final answer. I hope that this question is understand now. So this is again very important questions for JEE Mains 2027, because it is also the trend that if such type of question they are asking in the last JEE Advanced Examination, they will definitely ask the question, same question or the slightly data change questions on the coming 2 year JEE Mains examination, correct? I am giving you one more question on that. If suppose that set is containing 1, 2, 3, 4 and 5. Consider the set X, that is R, where R is an equivalence relation on the set S such that R has exactly 11 elements. Then find the number of elements in X. Okay. Now you can understand this question very easily. We have to just make the partition. Okay. Because the partition must follow that rule. What is that rule? For example, here 5. Okay. 5 elements are there. So how I can partition this? I can partition it as a okay. Now this is 3, 1, 1. 3, 1, 1. So 3 plus 1, 4. 4 plus 1 is 5. And 3 ka square gives 9. 1 ka square gives 1. 1 ka square gives 1. 9 plus 1 is 11. Correct? Is there any other way we can partition? Okay, 5, 2, 2 and 1. But 2 ka square 4. This is again 4. 4 plus 4, 8. 8 plus 1 is 9, not 11. Correct? Not 11. That is also give the equivalence relation defined over the set S. But we want an equivalence relation defined over the set that exactly contains 11 elements. So therefore this case is not possible. One can think like that. 5 can be divided like that. In 5 ways, 1, 1, 1, 1, 1. That is 5. But that is also exactly 11. Not like that. So therefore this is the only way. So therefore 5 factorial divided by 3 factorial. 1 factorial, 1 factorial. 2 times therefore 1 upon 2 factorial. This is 5 into 4. This is 2. 5 means 10. 10 is your answer. Mains level question. Very nice question. Correct? And they have asked slightly different, slightly difficult questions on advanced level. I hope that now this topic is covered.